If data transfer speeds aren't a big problem for you and you can't justify the expenses that come with Direct Connect, you can still add significant security to your connections using a VPN. There are two ways to do this. In this module, we'll explore the AWS approach using their customer gateways, virtual private gateways, and VPN connections tools to create a managed connection. In the next and final module of the course, I'll show you how to allow connectivity between your VPC and remote users using your own homemade VPN. But first, just what is a VPN? A virtual private network provides a direct, authenticated, and encrypted connection between devices communicating across an insecure network. They give you the ability to extend secure connections beyond the shell level, which can be handled more easily using protocols like SSH, to include just about any carrier protocol, including HTTP browser access. In AWS speak, a VPN is a bit simpler, referring to the connection between your VPC and your own network. By that token, technically, Direct Connect itself is nothing more than a VPN. AWS VPNs encrypt network traffic using IPsec, which stands for Internet Protocol Security. It might be more accurate to describe IPsec as a collection of protocols that can be configured and deployed through software administration packages. Should you be curious, I spend some time describing the inner workings of IPsec VPNs in the VPN module of my Pluralsight Linux Network Security course. But right now we're interested in the AWS way of doing things. Just as you saw with Direct Connect, a managed VPN connects to your VPC through a virtual private gateway, often described as a VPN concentrator. A customer gateway will define your local network and its connection essentials, and the VPN connection tool incorporates your VPG and customer gateway into a live connection. When all that's set up, you'll be given a detailed set of instructions for configuring your end of the tunnel. In the next clip, we'll see how all this works, but for now, I'm going to cover a few important points. A managed AWS VPN might be made up of a collection of fancy virtual devices, but the same basic and best practice networking procedures will still apply. Therefore, no different than Direct Connect, or your own local networks for that matter, you'll need to consider things like redundancy. A single VPN is just that, a single VPN. If any one of the moving parts should fail for any reason, the whole thing will die. The VPN tunnel is initiated by activity from your local end. If there is no activity for more than a rather short while, the tunnel will go down. To make sure that doesn't happen, configure your local monitoring tool to generate regular keep-alive pings. AWS VPNs can connect to a wide range of routing devices at your end, but there are limits. To find out whether the hardware you've got running or the devices you're planning to purchase are compatible, check out the Amazon VPC facts page. Scroll down to the Which Customer Gateway Devices Can I Use to Connect to Amazon VPC section for a list of required protocols that your device should support, and then a bit further to the What Customer Gateway Devices Are Known to Work with Amazon VPC section for the devices that are currently known to work with VPN connections. It's always best to plan ahead rather than face unexpected surprises. You can see how much a VPN connection will cost you on the AWS Amazon.com/VPC/pricing page. Finally, the odds are that you'll encounter only one kind of managed VPN, but older accounts might still have an earlier iteration, now called Classic VPN. I'm not aware of any downside to using the current version, but there are some definite advantages, including CloudWatch integration and more encryption options. Now, on to the practical stuff. Assuming your local infrastructure is all in place, including an internet-facing router, we'll start putting everything together at the AWS end. As always, it's important to confirm that you're in the right AWS region. The tools we'll need can all be found in the VPC dashboard by scrolling down the left panel to VPN connections. The order the links appear here is a reasonable order to follow, so I'll click Customer Gateways, and then Create Customer Gateway. Everything's pretty straightforward. I'll enter a useful identifying name that'll be used as a tag for the gateway. Now, if I were to choose Dynamic for my routing protocol, I would enter a BGP ASN here. Of course, this would only work if I had a router that's actually running BGP back at my office. For this demo, I'll go with Static. ASN, by the way, stands for Autonomous System Number, which serves as an identifier for a connected device or network within a larger network. Either way, though, I'll need to provide an IP address. Since this is just a demo, the address I'm using isn't real, or at least I hope it's not. That'll hopefully put our VPN in touch with our local router. Next, we'll need to create a virtual private gateway that will serve as a link into our target VPC, meaning the VPC that hosts the resources we're trying to connect to. I'll go to create a VPG and give it a tag. It makes sense to use the same naming convention for all the pieces of this VPN, so test it is. I could use a custom ASN, but barring extenuating circumstances, the Amazon default will be fine. That's all we need here. I'll create the VPG and close the window. Notice how the VPG state is reported as detached. That, since AWS can't yet read your mind, is because they have no way of knowing which VPC you're looking to connect. With the VPG selected, I'll click the Actions pull-down and click Attach to VPC. Here, I'll click once inside the VPC box and select the VPC I'm after. Be careful to choose the right one. The Yes Attach button will do the rest. Note the new VPG status. Now on to the VPN connection. Create VPN connection will take us to a page where we'll select the VPG, an existing customer gateway we previously created, and select a routing option. If I had BGP, then that would be the best choice, as it would automatically manage all the routing for me. But for this test, I'll go with static. I'll need to enter at least one CIDR address range from my local network that I'd like advertised to the VPC. Of course, I can add multiple ranges, but I have to make very sure that none of those ranges overlap with any of the subnets associated with the VPC. If there is anything wrong with my configuration, AWS will show me error messages here. But if everything went well, we can head back to the VPN Connections dashboard and check the connection state. You'll probably see pending for a few minutes, but that will eventually change to available. Either way, there will probably still be some router configuration necessary at your local end. As I mentioned back in the Direct Connect module, AWS provides personalized configuration guides wherever possible, and VPN connections are no exception. With our VPN configuration selected, click the Download Configuration button and look through the vendor, platform, and software menus for the best match with your local router profile, and then hit Download. There's also a generic option if you don't find an exact match. I've included sample Cisco and generic configurations along with my course documentation page at bootstrap-it.com/AWS-connect. As you can see, the files contain lots of helpful documentation along with pre-shared keys and the configuration settings you'll need to apply to your routers to make the IPsec tunnel work. If you need help making all this happen on your hardware, Pluralsight has lots of great courses on administrating at least Cisco and Juniper routing. Let's take a quick look at what we saw here. We talked about the function and purpose of VPNs in the context of server connectivity, and then about how they're used to access AWS VPCs. We learned about some VPN design considerations and best practices, along with a look at your hardware options and how much it'll all cost you. We then set up a managed VPN connection, at least from the AWS side, by building a customer gateway to define your local routing connection, a virtual private gateway to connect with your VPC, and then glued it all together with a VPN connection. Finally, after launching the connection, we saw how AWS provides configuration guides meant to help you with a wide range of hardware routing options. Next, we'll build our own VPN to connect clients with our VPC. Find this useful? Why not follow the link in the description and head over to view the complete course on Pluralsight. And of course, for even more technology goodness, don't forget to subscribe to this channel.